Okay, so I'm back from dinner and I got a request to do number 10. I'll probably just go ahead and do the rest of them, or at least the ones that I've done so far, and kind of just talk them through. So I guess this would be test review part 2. Okay, if we look at number 10, it is still a square root function. It is still a square root function, so we will go ahead and use the parent function and use everything as a square root function. So what we're going to look at is this is going to be the first blank. F of x is equal to the square root of x. The transformations. Notice we have a negative symbol and a 1/2 and then x plus 4. So what's going on? The first thing that's going on is the negative. We know that a negative is a reflection over the x-axis. Okay? And then the next thing we're looking at is, since this number right here is less than 1, it's going to be a shrink, a vertical shrink by 1/2. Now, clearly I am running out of space because I write pretty largely, so I'm going to put this one over here in the margins. The last thing that we are looking at is a horizontal translation left 4 units. Okay, so how does that correspond to our tables? Well, the parent function is always the same, so it's the same as number 9. 0, 1, 4, 9, and 16. Again, I kind of write pretty large, so I'm going to kind of zoom in and hopefully get it done. I'll zoom back out so that we can look at it a little bit better. Again, 0, 1, whoops, if I can get off of the eraser. 0, 1, 4, 9, and 16. The square root of 0, 1, 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Square root of 16, 4. That's our parent table. This is always the case. So our new table, our transformation table, is, I'm going to zoom back out and take a look. Take a look at this. Again, if you were following along with my videos before, this affects our x. Everything outside of that, okay, if there's anything here and there's anything over here, that affects our y. Okay? I'm going to erase. So, the first thing that I'm going to talk about, oops, if I can work my thing, is what happens to our x. I told you it was the opposite. Okay, so instead of adding 4, we're going to take our x value and we're going to subtract 4. Okay, subtract 4. And then from there, whatever's left, I've already used this. I'm going to take this negative 1/2. Okay, yes, I'm including the negative. I don't know what I did to kind of maybe confuse you on that, but let me get it out of your head. Anything outside of the radical, you have to put in that y, okay? If it's a coefficient in front of my radical symbol, a coefficient means we're multiplying by that number. So it's negative 1/2 times y, and there is nothing outside of that radical symbol, so we're not moving up or down. We're going to stay right there at the origin. Okay? So how does that look? Take my x values, plug it in. Negative 4, negative 3, 0, 5, and 16 minus 4 is 12. 12 is not on our graph, so I'm not going to put it in my table. Again, I write pretty largely, so I shall clean this up a little bit for you guys. Negative 4, negative 3, 0, 5, and 12. There we go. That looks better. All right. the next part is to find our y values, okay? Again, our y values, I like pretty colors, by the way, so sorry for all the colors. Our y values are these values. So I'm going to plug them in to that y right there. Negative 1/2 times 0. That is going to stay 0, okay? 1 times negative 1/2 is a negative 1/2, or you can say a negative 0.5. I don't care. Whichever one you're more comfortable with, go for it. Okay? We're going to continue. Negative 1/2 times 2 gives me a negative 1. 3, I'm on this one right here. 3 times a negative 1/2 gives me a negative 3/2. Okay? Negative 3/2, or a negative 1.5. And then 4 times negative 1/2 is simply negative 2. Okay? So far, so good. So we have to now plot these points. All right? So here we go. Negative 4, 0. Right there. There's nothing past that. We're not going anywhere else. That's where we begin our graph. The next point, negative 3, negative 1/2. So we're going to go to negative 3, and we're going to kind of zoom in a lot here because I want to make sure I get that point correctly. I don't care where it is, as long as it's in between negative 1 and negative 1, as long as it's between negative 1 and 0. That's what I'm looking for, okay? All right. Now, the next point we're looking at is 0, negative 1. So I'll put a nice big dot right there. And then 5, negative 1.5. And the other one is off the graph. So by this point, you should figure out that our graph is starting at the x-axis and reflecting like it's supposed to and curving downward, okay? It is not curving upwards, it's curving downward. You need to pay attention to that because since it's a curve downward, we technically have a decreasing function. We are going to pretty much have all this water spill downhill and eventually just cover all of these negative values, these negative y values to be exact, okay? All of that water is just slipping down this graph and it's just a massive slide, okay? So, that's very important when we do our graph characteristics. That makes our domain. So let's just go in for it. The domain, that makes the domain of our function what? Well, remember I said the domain we're reading from left to right. So where do we begin our graph? Well, if we look at it, we begin our graph at negative 4. So I'm going to put a bracket because, again, we're equal to negative 4. And then we keep on going. And we come into this arrow. When I say you have an arrow, especially if it's pointing right, it's going to positive infinity, okay? Now, this is where it becomes a little backwards. What do I mean? Okay, what I mean by backwards is this, okay? I'm going to go back to this real quick. I'm going to regraph it. When we do our range, I'm going to change colors just because I can. And I'm going to really try to show you the range. We read from the bottom going upwards. So I'm going to really just kind of start looking at the bottom. And what's the first thing I hit? It's this arrow. If we're looking at the range, this arrow is technically pointed downward. It will eventually, as I see, look at that. Look what's happening. It's slowly decreasing and it will hit every single y value. But not every single positive y value. It will hit every single negative y value. So we can say the first thing, the smallest y value is negative infinity. Okay? Don't put 0. It's negative infinity. Now, we're going to continue going up, and look what we hit. The highest point right here is at the origin. Okay? So that means that my y value goes to 0. Okay? That's the highest point. There is no other y value greater than 0 because there's no other point that will get a true solution above the origin. I'm sorry for my poor sketching. This is what happens. Okay? That is how you do it. Okay? That is how you look at it. Okay? So I'm going to zoom it all out, let you see everything. Because I'm going to scroll down because we got to talk about end behavior. Okay? But that is what your domain and range is. Okay? If you have questions on that, please come to me, please ask me, and we will discuss it. Okay? So, end behavior. I don't know, can I write down here? No, I can't. End behavior, again, from the previous video, I told you the end behavior, I'm going to do a really pale peach color, is our x values is our first end behavior, and then our y values for our domain and range are our next end behavior. Okay, it matches, it makes sense. So as x goes to -4, y goes to negative infinity. Again, as x goes to -4, y goes to negative infinity. The next end behavior, which is going to be this arrow right here, as x goes to positive infinity, y will go to what? 0. And that is how it matches. That would be how you do number 10.